Welcome everyone to our first community call in 2021. Happy New Year. Well, we're almost a month in, but still, it's pretty not too late. Um, and Today, I'm Manish. I'm the founder and CEO of Dgraph Labs, and along with me are a bunch of Dgraphers. Let's start with Vijay.
Yeah, thanks, Manish. Hello, everyone. Pleasure to be here and meet with all of you virtually. I'm Vijay Ratnam. I'm VP of the India engineering team and head of Dgraph Labs India.
Next up, we have Daniel. Daniel, you are muted.
Hey folks, yeah, thanks Manish. I'm the head of customer success here at Dgraph, and I see a lot of familiar names in the chat, so great to see everybody joining.
Next up, we have Tejas.
Hey everyone, yeah, I guess I spoke at the last community call as well, so you should be hopefully a little bit used to me by now. Yeah, and I'm here to, we'll have quite a few announcements for Slash GraphQL and Dgraph Cloud, so quite excited about that.
We have Anand.
Yeah, hi, this is Anand. I'm a customer success engineer working with the customer success team. Today, I'll be demonstrating business rules with Dgraph, and it's my first opportunity to present as well. So hello to everyone.
Thanks, Anand. And next up, we have Ibrahim.
Hey everyone, I'm Ibrahim. I lead the team that works on Dgraph.
Ibrahim is the lead for Dgraph Core. And we also have a couple more folks, Phoebe and Balaji, if you guys are around, if you can introduce yourself quickly.
Hey everyone,
I'm Balaji.
Oh,
Sorry, go ahead.
That's my bad. Go ahead, Balaji.
Thanks, Manish. Sorry, Phoebe. Hi, I'm Balaji. I manage the engineering team responsible for building the graph database Dgraph. Hi, everyone.
Thanks, Balaji. Go ahead, Phoebe.
Hi everyone. I'm Phoebe. I work on the marketing team at Dgraph as a marketing specialist, and we're happy to have you all here today with us.
And we also have one Dgraph Labs, and that's our head of marketing. Zani, do you want to quickly introduce yourself?
Hi, everybody. My name is Zenny. I'm the director for marketing, and today we're working with Phoebe along with the team to monitor the chat, and so glad for everyone being here.
Great. And we have our special guest, Vignesh. Vignesh, if you can just quickly introduce yourself.
Hi everyone, so this is Vignesh. So I am the founder of Timecampus, a startup which is working on a time management platform. And probably when the session starts, I will give you more details about me.
Yeah, we're really looking forward to the talk by Vignesh, and we have a really amazing and full agenda for you guys. If you have any questions, as usual, if you have any questions about about any of the things that we're going to discuss, please go to bit.ly/dgraph-call-5. This is our 5th call, as you can imagine by the numbers. And we are recording this call, of course, and this will be available on YouTube tomorrow. So for people who cannot make it or people who want to listen to it again. All right, let's move on to the agenda. So we'll first start with some updates from the Dgraph team. We made a big release, the 20.11 tenacious, the Chala release of Dgraph, which has a whole bunch of really amazing updates. And then we also changed or updated the pricing for Slash GraphQL. So we're going to talk about that. Next up, we'll have the presentation by Vignesh from Timecampus. We'll look into how do we do business rules, how do we set and query business rules. Anand is going to give a presentation about that, and finally we'll have the last 10 minutes for Q&A. And if we can't get to everybody's Q&A, if you just put your questions on the link listed here, we will still respond to it after the call, because that goes to discourse, and we try to respond to as many questions as we can on our forum. All right, great. Let's, oh yeah, one more thing is that we are going to have a Dgraph Day We are aiming for it in first week of April. Is that right, guys?
April 15th.
April 15th. All right. So this is a good opportunity for you to go in and submit CFP. So you can be a presenter. We are really interested in all the different ways people have used Dgraph and Dgraph's GraphQL to build interesting stuff. And the more interesting stuff that you have built, the higher the chance that your CFP would be selected. But feel free to reach out. If you are, hey, would this idea that I have, would it be useful or not to submit, just reach out to the Dgraph team and we will help you, guide you in what kind of submissions have a higher chance of selection. So yeah, so definitely check it out and submit your CFPs. Next. All right. So for the Chala updates, I'll give it over to Daniel.
All right, so for the Tenacious T'Challa release, the V2011 release, we made a lot of improvements here. The key highlights are speed and performance. So I think a lot of folks were reporting to us that, Dgraph was taking up a lot of memory and was also getting out of memory kills. So we made a lot of changes to make sure that Dgraph can perform well with just only 32 gigs of RAM per Dgraph Alpha instance. And so now you can scale to terabytes of data with those sort of commodity machines. And we also improved bulk loader quite a lot, at 58% improvement. So for folks who are using bulk loader heavily, you can now get higher throughput with that. And especially for large data sets, you don't have to wait many hours. You can wait, you can be much quicker than that. We also support batch upserts in live loader. So before you can just load new data, overwrite existing data in live loader, but now you can do upserts, so you can update existing nodes based on a certain predicate XID, and you can also instead of having to just overwrite or reload the data, you can update existing ones now. We also have RDF query response support. So typically every single query in Dgraph returns back a JSON response, but for queries where you need to have better performance, you can also return them back in RDF format, which is a sort of a stream format, a flatter list of data points that get returned. So instead of having to traverse the entire JSON tree and build out that deeply nested structure, we can actually give you quicker response times through RDF. That's available in 2011 as well.
And just a note about some of the scalability and performance stuff that we did. I think after the 2007 release, we found a bunch of issues with Dgraph's performance, and plus we were working with a big customer of ours who has dozens of terabytes of data. So we ran a war room in Dgraph for around 4 months to be able to deal with the dozens of terabytes of data that was being thrown at Dgraph. And we made just tons of improvement all across the board to get to a place where you can run a bulk loader, you can live load data to Dgraph with only 32 gigabytes of RAM and never exceeding that RAM, and not to mention introduction of JMalloc to do better memory management, because we were not quite happy with the way Go was managing memory. Together, a few of these things combined across the board have made a huge difference to how well Dgraph runs and how fast it runs and how well it works with giant data sets.
Yep. And so, we made all those improvements there. And the GraphQL specific improvements include a lot of things that the community has been asking for, like aggregate queries and union types, support for the geo types in GraphQL, authentication with JWK, which allows you to use other services like Firebase Auth for authentication in Dgraph, authorization rules on top of interface types, persisted queries, so you can save queries and execute them without having to send the entire query over again back through GraphQL, and schema versioning, so you can keep the history of your schema changes within Dgraph and be able to understand what changes you've made in your schema. In terms of security for Dgraph, we made some changes in terms of security. So I think first and foremost, we support MTLS within internal cluster communication, and all that handshake is done at a minimum version of TLS v1.2 now. Before it was 1.1, so we bumped that up. And we also enable TLS for 0. So before it used to just be between the client and alpha for the queries and all the sort of requests between the client and the server, but now we also enable that for 0 as well. So you can get that same security guarantees for the admin endpoints, which are typically accessed just by sort of internal users. And even though MTLS is sort of supported now across the board for all instances in Dgraph, things like Slash Health are still available both on HTTPS TLS, but also just plain text HTTP, which allows things like Kubernetes liveness probes to be still set up properly. And we also have encrypted the RAF write-ahead log. So that's the write-ahead log on disk. That's also encrypted if you have the enterprise feature for encryption enabled. And some more improvements in this version as well are the Lambda resolvers for custom queries. So instead of having to spin up your own backend server that handles custom queries in GraphQL, you can also have these Lambda functions in JavaScript that Tejas had demoed in a previous community call, all through Lambda powering these custom queries. A speed up for recursive queries, so you have like these deeply nested results using recurse. There's improvements there. There is changes around how we do data cleanups on disk with rollups in Dgraph. And as Vignesh mentioned, there's manual memory management via JMalloc across the board, and faster compression using Snappy, and there's also updates to ludicrous mode, so you can now run mutations from the same predicate concurrently without having to worry about consistency issues there. And there's also changes in the latest patch release, which we had just released this morning. So 2011.1, things like bulk loader or even JMalloc is now supported on macOS builds. So a lot of bug fixes in both GraphQL, Dgraph, and various aspects in the latest patch.
And I think something about the efficient garbage collection on disk, I think that's actually, a much bigger change in how Badger, which is our key value database underneath Dgraph, how that works with the value logs. And, Badger was the first database which was, which was trying to use value logs for data storage based upon a paper that we had picked up in 2017 called Whiskey. But the paper did not have some of these really important things about, hey, how much disk would it be using, would the value log be using when you actually write a lot of data. And we saw multiple companies trying to tackle that problem based upon taking inspiration from us, including PingCap, where they built a key value database with the value log idea that we had, but we couldn't find any straightforward way or a simpler way to be able to deal with the pace at which the disk gets used. And so one of the big efforts that we did was to revamp how we store data on disk and how we use value logs to be able to separate the usage of value logs as write-ahead logs. So now we have separate write-ahead logs and a separate value log. And that ways we can reclaim the write-ahead log much faster, and value log only contains the super important, really big values. And that actually made a huge difference to the terabytes of data that we were loading into Dgraph. And now Ibrahim's team is doing even more work to further sort of like fine tune when does value log get used to make it even better. So I think that makes Badger quite unique in its category because it still gives the LSM trees actually it gives you better than LSM trees performance because of the usage of value log without necessarily having to use up tons of extra disk space. So it's pretty interesting if you dig into the details there, even though it's just one liner over here, right? But that's always the case, right? About any of the exciting technologies, the manual memory management was just such a big change across the board, and ludicrous mode and so on and so forth. So really excited about what 2011 has. And if you guys are using any of the previous versions, I know upgrading is a pain always. But I would I would highly recommend you guys to upgrade, because the kind of performance improvements and disk usage improvement and just improvements across the board that we have gotten, memory improvements and stuff, are well worth it, worth the pain of upgrade. So please do. Okay, next slide.
Great. With that, I'll hand it over to Tejas.
Hey, yeah, thanks for that, Daniel. So I'm actually pretty excited about whatever we have to announce. So the first thing that we wanted to announce is we've been getting a lot of queries about Slash GraphQL. People have been using it for all sorts of use cases. And I think one thing that came across consistently. Sorry, Daniel, do you mind going to the next slide? Yeah, so the one thing that came across pretty consistently is people were looking for creating like a large number of backends, and we're wondering how they could do this in an affordable way. We've drastically simplified our pricing. I think maybe the last community call, what we had said was we were looking at had credits-based pricing, and we were starting somewhere around $50 to $100. We've reduced our prices significantly. We're now at $9.99 per backend per month, and each backend gives you 5 GB of data transfer, and you pay for 2 GB beyond that. Using this, you can scale between, if 1 month you just want a single backend, and then next month you want 10 or 100. We have great, we've been getting a lot of queries. The biggest request we have had is that somebody was trying to launch, I think 600 to 1,000 backends on Slash GraphQL. They didn't do it in the end, but I think they're well on their way. Each of the backends supports up to 25 gigs of data storage, and of course the data transfer is additionally charged at $2 per GB beyond your 5 GB limit. We've also been working on quite a bit.
Go ahead, Taya. Sorry, I'll just add something toward the end once you're done with the slide.
Yeah, I'm done with this slide.
Okay, and I think just something to note here is that if you actually do have multiple backends in your Slash account, and the way Slash account works is that you can have a team of people, so that there's 3 or 4 people who have access to those backends in your team. Just makes it easier. So if you do have multiple backends, the 5 GB data transfer, it actually gets pooled, like a family plan and in other places. So the data gets pooled, so you do not have to pay. So if you have 4 backends, you get basically 20 gigabytes of data transfer, irrespective of wherever it comes from. We just sum it up, and then we charge on top of that the extra $2 per gigabyte of additional data transfer. And we are not charging for storage, right? We are not charging any extra money for storage, but we are limiting it to 25 gigabytes per backend, because this is our shared instances where it's bigger Dgraph instances which are being shared across multiple tenants of Dgraph. And after 25 gigabytes of storage, we would expect people, or we will tell user to switch to a dedicated Dgraph instance where you have a lot more control over all of these parameters.
Yep, and more on that is coming up in a few slides. So we are continuously working on Slash GraphQL features as well. Next slide, please, Daniel. One thing that's currently still work in progress, but I wanted to give a small teaser over here, is we are very committed to making developers' lives easy. We want to make this sort of no code or low code experience. We want to make this sort of possible. So in addition to our schema builder, which I think is pretty unique amongst the various GraphQL tools and services out there, we've been working on something we call the data visualizer. This basically is a very simple interface where you can kind of see all your types on the left, click on it, you can see the items in that type, and then click, and then further drill down further and further. So in this case, you can see I've clicked on collections. From there, I clicked on the films in that, and I think it's not visible in the picture, but I've clicked on the art direction. And so and what this does is you can drill down into your actual data, and you can see some the UIDs and stuff of the Dgraph entities all around, and then you can finally click at the bottom to generate the GraphQL query, where it'll take you to the API Explorer, and you can just run the query right there. And even from there you can even get it in code. So we're still working on this. There's still quite a few bugs that we're ironing out. I think it might be available for you right now, but it's still a work in progress. And I think next month or next community call, we're going to have a lot of updates on the data visualizer as well as the schema. I just wanted as well as the schema builder. Just wanted to leave this as a teaser over here. Next slide, please, Daniel. And so coming back to Manish's question, so what happens when you cross your 25 gigs of limit? We are now very happy to announce dedicated instances. Okay, so under Dgraph Cloud, we are now launching dedicated instances for users, which will allow you to scale to terabytes of data. These instances will be dedicated on our Kubernetes network. It's fully managed by us, and you'll have a number of features that are not available for Slash GraphQL, such as launching high availability clusters, support for ACLs, VPC peering, which is coming soon. There's actually 2 points which somehow didn't get reflected in the slide. The most important of which is bulk loader. Bulk loader has been very, very commonly asked by almost everyone that we're talking to. Slash GraphQL doesn't support it yet because maybe for the 5 or 10 up to 25 GB that you'd put into a Slash GraphQL instance, maybe it's not the most important. But when you're dealing with large amounts of data, we are going to support bulk loader with dedicated instances. And the last thing is monitoring dashboards. So you'll get a lot more insight into what's going on in your Dgraph instance through this monitoring dashboard. Next slide, Daniel, please.
Tejas, could you maybe show them the pricing calculator and just maybe come up with a rough spec whenever you have a chance?
Right. So I'll show that just after this. But just coming to the monitoring dashboard, if you already have a Dgraph a Dgraph Cloud dedicated instance that you've asked us to provision for you, you'll see this new tab on the left which says monitoring, and you can see in this case I'm looking at the specs for play.dgraph.io, which does run on Dgraph Cloud, by the way, and you can see how much CPU memory, various queries. You'll have more advanced dashboards for how many what the raft ID is and how many transactions have aborted. A lot of great metrics which will help you get insights into what's going on into your Dgraph instance. Okay, so which brings me to the last thing that I had on that slide is we also have built a small calculator for you to estimate how much your build of Dgraph would cost, how much it would cost you to launch a cluster on Dgraph Cloud. I'm sharing the version, but this might this UI might change a little bit by tomorrow. But so you can come to slash.dgraph.io/the pricing calculator. You can look and say, okay, you know what, I'm trying to launch in AWS in Oregon, and I'm thinking of launching a machine with 4 GB of RAM, or 4 vCPUs, 16 GB of RAM. I need, let's say, 1 terabyte of storage, and I need this to be highly available. Okay, so it'll tell you what the price is per month, and from there you can kind of launch a request to us, and we'll help set this up for you. This will be completely self-service very soon. Hopefully by the next community call, you wouldn't need to actually go through this and contact us. You'll just be, there'll be a button somewhere within Dgraph Cloud or Slash GraphQL, and just says, launch this as a dedicated instance. And we'll be.
Here's, could you show what's the cheapest instance that you can have in
Yep. So the cheapest instance probably this is.
You'll have to remove the high availability stuff.
Right. Yeah. So that's the mistake I made. Yeah. So the cheapest is around 220 starting at. If you take a little bit less storage, I think it comes down to around 199.
And also there's difference in the pricing of different regions. right? For example, I think sometimes Google is cheaper than Amazon, and sometimes Azure is cheaper, and so on and so forth. So all of these variations are reflected in our pricing calculator. Like behind the scenes, we have a very sophisticated model that we use to figure all this out. So if somebody is like, you know what, I don't care about which cloud provider, I just want the cheaper way to get started, you can try out different regions and see, you know, what would work best for you. And we do support a bunch of regions if you go up slightly there, you know, in Amazon and Google Cloud. And what we plan to do is to add more regions so that it would work seamlessly with wherever your service is running today. So you can probably get an instance of Dgraph in the same zone.
Yep. And with that, that's the end of the updates for Slash GraphQL and Dgraph Cloud. I think that's back to you, Manish.
All right, let's go to the next slide. If you can get the slides back. All right. Yeah. So next up, I'm really excited about this talk by Vignesh, the founder and CEO of Timecampus. So take it away, Vignesh.
Thanks, Manish. So I will quickly show you my screen. Okay. So I hope you are able to see it live on the screen.
Yes, we can.
Okay. So thank you for having me here. So, and today I'm going to talk about our journey with Dgraph at Timecampus. So before I go ahead with introducing Dgraph and the context on how we use it, so let's quickly have an introduction to who I am and probably the startup which I'm working on. So myself, Vignesh, so I'm a solopreneur. So I should not say, a complete entrepreneur, because, I work alone right now to get the market validation out. So, and being a solopreneur, I basically wear multiple hats, being the developer, architect, and product manager. So yeah, basically playing around with everything. So I like to call myself a generalist, considering that, I am basically jack of all trades. So yeah, this is all me, and probably you can reach out to me over social media. And this is Timecampus, the startup which I started off the journey with probably around 6 to 7 months ago. So Timecampus is a time management platform for users and businesses. Basically, what we try to do is we try to help users and businesses observe, analyze, and optimize the time they spend. So this is the vision and mission. If you see here, give your time the value it really deserves. So time is a big asset to everyone. That goes without saying, irrespective of whether you are in a leadership position or you are a developer. So it doesn't matter. So time is a important asset to everyone, and that's exactly what our vision is, to basically give users a platform where they can actually explore the time they have spent, analyze it and see where they are going wrong or deviating from their goals. And finally, depending on the use case, so you can optimize it. So probably, and we are a bootstrap startup. So we are launching soon, probably in the first quarter of 2021. And yeah, this is a quick snapshot of what I just told you. So observe time from multiple platforms or events from multiple platforms, be it Facebook, or you are attending a meeting. So all the time is captured, and then you analyze the time which is collected. And finally, depending on the use case, we provide optimization options. So we can't satisfy every use case for optimization. So what we do is we provide you with a platform or building blocks, which users, almost like a Lego block, so which users can play around with to, create a workflow for the use case. So that's what we aim to do, and we'll be there soon in 2 months. So, and to give you a context on what we do to basically enable all of this. So this is the stack which we use. In fact, I was not able to fit all of this into one slide. So I tried to manage as many icons as possible here. And by the way, this is the stack which we really use. So, and you can see Dgraph right out here. So we work on the cloud native stack basically. And this is the benefits of having a startup at this day, right? So you can basically play around with all the cutting edge technology, and especially it's not just You're not using this because it is cutting edge. It's solving most of the important problems we have. For instance, we are using web components for the user interface, GraphQL for all the querying, Kubernetes for our infrastructure management and orchestration. Google Cloud is where we are hosted. Terraform is what we use for managing our infra as code. So like this, I can't take you through all of this. Probably this will take a complete series all by itself. So this is just to give you a context on the stack which we work with. And as everything goes, we didn't reach here directly, so it took a lot of steps to reach here. So this is what we, in fact, we have had 4 to 5 iterations with Timecampus. Yeah, of course, not launched publicly, but we had internal iterations. And this is how it looked before. So the database was initially Postgres, not Dgraph. And it was microservices architecture with multiple services. And we used Prisma for managing, Prisma is the ORM for managing all the, queries and operations to the Postgres database. And, we had GraphQL on top using Apollo Federation. That's how we used to maintain this before. But as and when we started exploring more and more, that's when I realized a lot of challenges in this kind of a scenario. By the way, there is a mistake in the slide here. So everything says service A, so service A, service B. So multiple different microservices with each having its own database instance. So I was paranoid that I should not have a single database instance. So I split it like this. So now talking about an architecture like this, the biggest problem you face is the complexity. So you can make a bleeding edge architecture, you can use all the technologies you have around the world, but the problem you have is that as and when you add each and every technical component to your architecture, the complexity increases and basically it becomes unmaintainable, especially for someone who is working alone on his startup right now. So yeah, so these are the main challenges we started realizing. So first important problem is data and relational boundaries. So when you're talking about a microservices architecture, you have isolated instances, right? So each and every database has its own scope of partition on what it can store, its own schema rather. So if you are building a true microservices platform. So I do see organizations who claim to have a microservices platform, but ultimately the database is one. So that doesn't make any sense because ultimately you are still having the bottleneck in the database layer, which is not recommended. So that's why I thought, okay, let's have it as a true microservice architecture. But then what happened was, when you are developing a product, you want to think of the business boundaries. You want to think of the problem you are actually solving rather than having to worry about the underlying storage. So that's what I felt personally. And not just that, it was very difficult to find everything upfront. Like, how do I know that this has to go in this database without even building out the complete feature set? So then again, I had to move one schema from one database to another database, move all the data as well. So that was the problem with data and relational boundaries, because I was making a lot of cross microservice calls and cross database calls when I was using this kind of an architecture. Second important problem I had is I had to clearly know which database instance had a respective schema, because when you are using Prisma or any ORM or any provider for that matter, you before you make any query to the database, you need to know, where is the respective data. So unless you know that, you can't make the query there, right? So that was again a problem. Because it was an implementation detail according to me. So it's not something which you should worry about when you are working on your product. The next problem I had was, Postgres is not initially built to be cloud native. Yes, you can use it in cloud native. In fact, I feel that a lot of people in the Postgres community may hate me for this. But this is a fact. So Postgres, what do I mean by saying it is not cloud native? So basically, it is not built for elasticity, fault tolerance, horizontal scalability, like a normal database. A normal cloud native database should be built, and also sharding across multiple regions and geolocations. So these are all the important features. You can't assume that your database never fails. Rather, you should have a way to cater to such failures in a distributed architecture. So all of these things were not catered by Postgres. And then finally, it also required me to learn a syntax of Prisma, which is the ORM I was using. So basically, they have inspiration from GraphQL, but it is not GraphQL. So Prisma 1 was GraphQL, or it was called GraphQL rather, and then it became Prisma 2. And I should say, I should give credits to the Prisma team. Prisma is really great to work with. And I would definitely go back to Prisma if I use a relational database. But for Dgraph, it might not make sense. So I had to manage the migration. So version control migrations and everything when I use Prisma. And then I had to also add, this was a bigger challenge. In fact, I would say an advantage I feel from what Dgraph provides me with. So before coming to Dgraph, I did explore other graph database providers like Neo4j. I did look at TitanDB, Janus Graph and everything. So, and then finally what happened was I realized I had to maintain a parallel database, one a graph database and another basically a database with just the data, and have all of these working together in sync. So basically when I update the primary database, I have to also update the edges and vertices, which is a pain, especially considering that anything can fall apart anytime. So this is something which I found different in Dgraph, where it had the ability to store both data as well as edges and vertices. So I liked it better than the previous approach. And then finally, productivity was going to a huge toss because of all of this. I had to set up CI/CD for getting to all of this. Yeah, that's pretty much all the problems we faced. And now probably you might understand why we even chose Dgraph. So if you see the bold things highlighted in bold, it's a graph database. First hit for us because we ultimately realized that almost all data is related, irrespective of where it is stored. Somehow or the other, it will be related, at least at a point of time. And then it can also store data, as I told you, interact with the GraphQL API. I'm insanely excited about the GraphQL part, especially because I use a ton of GraphQL tools. I will be talking about them soon. So the GraphQL part of the equation was the most powerful thing for me. It's cloud native. I have it running in my Kubernetes cluster, and it works fine without any issues. And highly scalable. So as I told you, it's database is a modern database and it's running on Kubernetes cluster. And I'm not using Slash GraphQL right now because I am managing. I prefer to run it both on-premise as well as on cloud. So that's why I chose the Dgraph open source rather than Slash GraphQL. But if you want to quickly get started, Slash GraphQL can be a great option. And in fact, if you don't want to focus on on-premise, still it's a great option, especially if you want to scale up and leave the maintenance to the team. So and then it's written in Golang. Of course, if you remember the stack you see before, almost all the tools we use, starting from Kubernetes to Dgraph, everything is written in Golang, and I can clearly see the benefits using the tools built on Golang while we still use TypeScript on our end. So it's open source and great community. In fact, I post any question, I get a response immediately, almost immediately in the Discuss community. And then performance and competitors. I will talk about the performance analysis we did and how we compared others with Dgraph. And underlying storage is Badger. So we also explored who else uses Badger. And in fact, there are a ton of them. In fact, if you go to the docs, you can actually find a lot of interesting use cases for Badger without using Dgraph and other things. Yeah, and used by many other projects and is well funded. So all of this were the main decisions behind me choosing Dgraph. By the way, guys, in case I'm running too fast or we are running out of time, just let me know. Probably, we have quite a bit to talk of.
No, I think it's going at a great pace. Yeah, I'm following through, and we have time.
So yes, these were the links we referred to before starting off with Dgraph. There is a Dgraph blog post on the benchmarks itself, which dates back to 2017, I guess. But I should say, I was not, convinced after seeing the blog post. While the blog post was essentially good, the blog post was from Dgraph. So I wanted a competitor to basically, compare Dgraph. So I went to Neo4j, and I was not able to find any, anything comparing to Dgraph. So maybe Neo4j should also stand up to Dgraph and probably compare. That's what I feel. But they have pretty good benchmarks on why Dgraph is faster. You probably have to check all these links out. I can't talk about all of these in this session. And in fact, the best link I would suggest is the Jepsen test itself. They run through a comprehensive analysis on the underlying storage. They talk about the consistency models. They talk about the raft algorithms. So in fact, if you have to understand the nature in which Dgraph has been tested, it's best to start off with Jepsen. So you will get an idea. And I did look at other tests from Dgraph to measure their storage, resiliency, and everything. And finally, I also looked at DB engines, but I wouldn't recommend checking DB engines because they measure databases based on SEO and popularity rather than the performance itself. So Dgraph comes below the other competitors, but that's purely based on SEO. So I wouldn't recommend DB engines, but I still added it to the slides. And there is a great paper in the Dgraph website. You can actually have a look at it. So ultimately, I should say that I didn't go deep into any of these links. The reason I did refer this is because I wanted to see to what extent the Dgraph team has actually tested the database for resiliency, because I didn't have the bandwidth to test it myself. I wanted to have a look at how they have tested it. So now coming to now that we have settled with the decision of me choosing Dgraph, let's quickly jump into how we are using Dgraph at Timecampus. So, one important one important session which I actually came across is by Johan Schickling. I hope I'm pronouncing his name right. It's a great talk from Prisma or Apollo GraphQL, one of those talks, where he suggests how do you make a fully typed architecture starting from the client to the server, where you have the front-end layer as you see here, and which can be any client for that matter, mobile apps. You can have any kind of client, and you have an API layer, which is nothing but your GraphQL gateway, be it federation or stitching, you still have a gateway. So which basically orchestrates all those queries and mutations across multiple different microservices. And now each and every microservice has its own API, and that API can be either gRPC based or REST or even GraphQL. So that depends on your implementation. And then you have a data model for the respective microservice, and then you have a data access layer to basically query all the underlying databases. So and that's the pretty much end-to-end type architecture which he was talking about. And in his case, the data access layer would be Prisma, and here it would be something like Postgres. So, and this is the architecture which I showed you before with with whatever we had before. What we use right now is this, what you see in the right hand side. So our database is Dgraph, GraphQL, and instead of Prisma, we are using GraphQL Mesh. I will talk about GraphQL Mesh shortly. So that's pretty much like you can call it like an ORM, but it's not strictly an ORM. So I will talk about it. Then we are using TypeScript and code generator to basically have all the SDK and types working on the server side. So I will talk to you about that as well. And finally, from the client side, we are again using TypeScript and code generator. So if you see here, the end-to-end stack is completely typed. So here we have TypeScript, here we have TypeScript, and the mesh is also typed, and then finally comes to GraphQL. So the complete layer is typed based on the GraphQL endpoint which we have. So yeah. So now that that's probably addressed, so I will quickly take you through a typical GraphQL workflow. I'm not going to address all these points, just going to walk you through. So first, what we do is evaluation and research of all the use cases you want to do. Get a boilerplate ready, because GraphQL does require a significant amount of boilerplate. Then putting together the data graph and documentation. This is a really important step where people start ignoring a lot, but data graph is really important. So both in the database layer as well as in this case Dgraph. So on data graph on the client side. So I will talk about that. So deploying it all as per the need, mocking and testing client consumption, getting the resolvers and backend setup, optimizing the data path, controlling and securing the data path, testing, automating and scripting the repeatable paths. So basically, this is a complete workflow. And in case you want to read more about it, I'll probably leave a link in Discuss or in the chat later. You can have a look at the blog post which I wrote, where I'll be addressing all of these. So now coming to the Dgraph workflow. So GraphQL workflow, while it involves a lot of steps, that's pretty much GraphQL. Now, if you're talking about Dgraph itself, this is how we are using Dgraph in our context. So, sorry to say this is not a Go session here. So you might see a lot of TypeScript and Node.js here more than Golang. But yeah, this is how we use it. We have the Dgraph schema set up first, depending on what we want to have in the database. So we have our own view of the data. So we set up a Dgraph schema depending on what we want to have in the database, depending on the schemas. We connect it with GraphQL config, use GraphQL mesh, then write queries and mutation. Then we generate SDKs and types. I know I'm going fast. The reason is because I'm going to explain all these steps to you so that you get a clear picture out of it. So generating the SDK and types, using the types and SDK with variables to make database calls. So this is a workflow, which we use for using Dgraph. So now let me walk you through each and every one of these steps. So let me take a pause here and give you an idea on what this workflow looks like. So we have our database as Dgraph, which is going to expose a GraphQL endpoint to us, and which is pretty much the single source of truth. But one thing we don't do is, unlike Slash GraphQL, where you have the data graph directly exposed to the clients, we don't want to take that route. The main reason is because I feel that maybe a personal feeling, but the schema of the database and the schema of the client should be separate from each other, especially because one is the technical details behind the scenes, another one is the server based or client based details. Or you define your GraphQL schema based on the business, and you define the database schema based on the technical complexities or operational things in mind. So that's why we have two layers. Rather, we don't directly expose the Dgraph schema to the client, but what rather we do is we expose Dgraph, the endpoint, GraphQL endpoint, to the server side, where we have the GraphQL mesh running. And then we also have, we use the guild stack completely. We use schema stitching. So, we basically have our own GraphQL servers written in Fastify and, Fastify, Node.js, TypeScript, and yeah, pretty much the new gen schema stitching, so which I will be talking about. So let's quickly walk you through this step. So first important step is the database schema itself. So where we define, what is the schema of the database, what are the various fields, what are the types. So this is something which you know already if you are using Dgraph. So this is pretty much the basic step. But what we don't do is we don't expose this directly to the clients, as I told you. So the next step, what we do is, once the schema is set up, once the schema is set up, the next step we do is to get all the tooling working with the GraphQL endpoint, which got just exposed from GraphQL. We connect to it through GraphQL config. So GraphQL config is an open source project from the guild, which basically helps all the tools interact with a single configuration rather than splitting your configuration into multiple pieces. So for instance, I use the VS Code GraphQL extension, which talks to GraphQL config. I use GraphQL CodeGen, which talks to GraphQL config. So, and I use other extensions also, which talks to GraphQL config. So GraphQL config becomes the single source of truth for all my GraphQL configuration from a backend perspective. So if you see here, I basically mentioned that I am going to, define, I'm picking all the schema from my respective microservice schema files. Then I am also defining the configuration for my GraphQL CodeGen. So I say that, okay, taking the schema in mind and, adding all these plugins like TypeScript is what I use, right? So I use the TypeScript operations and TypeScript resolvers plugin and basically generate this TypeScript file. So this TypeScript file is going to have all the types. I'll, take you through it. I know I'm running at a huge pace, but 25 minutes is all we have, guys. So I hope you understand. Probably we will take it at a slower pace, or maybe you can read through my blog to understand it a bit more at your own pace. So yeah, we have all these things, mapping and everything in place, which basically defines, how to convert the respective GraphQL schema or the dgraph schema into TypeScript. So once this is done, the next step what we do is we use GraphQL mesh. Now coming to the GraphQL mesh, so it's almost like an ORM, but rather than just a database, it can basically interact with any data source. So SQL is one data source, gRPC is another, OpenAPI, then you have multiple other data sources, and what we are doing is we are using GraphQL mesh on top of Dgraph. So which means that we are using GraphQL mesh with GraphQL. So it is not needed. You can use Dgraph directly, but the reason why we are using this is because we want to keep the future in mind. Because let's assume that I want a secondary data source in addition to Dgraph. For instance, if I want to have a time series database, and Dgraph is not a good fit for a time series database right now, it's a graph database. So if you want to have a database like that, what I can do is I can have a time series database running along with Dgraph, put a GraphQL layer on top of it, and basically connect it with mesh. So ultimately, mesh will become a single point of query for all my databases or data sources, even external data sources. So if I am talking to the Stripe API or PayPal API, all I want to do is talk to GraphQL mesh, and GraphQL mesh will in turn take care of talking to the other data sources or providers. And this is pretty much all the configuration we need to basically configure GraphQL mesh with Dgraph. So just specify the GraphQL endpoint and say that you want to cache the introspection because you don't want it to repeatedly poll Dgraph, right? So you want to cache the introspection, and then finally save the file locally, and you can generate the mesh out of it. So mesh is like a ORM or a data source. Now talking about, I will take you through how we use mesh, but before that, the next important step is to define the queries and mutations itself. So as we are using Dgraph, and Dgraph is GraphQL, or I should not say Dgraph is GraphQL. Dgraph, GraphQL, and DQL both exist, right? So, since I am using the GraphQL part of Dgraph, so we define the queries and mutations on all the operations I want to do against the database. So in this case, let's assume that I want to get an author or add an author. So I define the queries and mutations as you normally would. And now what happens is once all of this is defined, my my GraphQL schema is defined, my config is defined, my queries and mutations is defined. So now if I run the code generator, this is what I will get in TypeScript ultimately as the result. So it will basically give me a TypeScript file or multiple TypeScript files with all the generated types. So here you see the scalar generated, all the types from Dgraph generated. This is not a file which was written manually by me, but purely generated from Dgraph using CodeGen. So I get a file like this. So with this, what I can do is I can make my server side completely typed. By that, what I mean is, so let's assume that I have to make a query to Dgraph or a mutation to Dgraph. All I have to do is run something like this in my SDK. So if I am using a GraphQL mesh, so and as I told you, GraphQL mesh is like an ORM. And GraphQL mesh also generates the types and TypeScript. So if you see here, the auth provider input is a generated type from the Dgraph schema, which is converted to TypeScript by the CodeGen. So I mean, let me repeat it again. So from the Dgraph schema, what we do is we generate the types, and the next step what we do is once the type is generated, we use the types in TypeScript. And in addition to that, we also have the SDK which we have generated to GraphQL mesh. So we are using all the operations in the SDK. So all I had to do is this .sdk.add auth provider, and this is generated. This is not a function which I defined. And the SDK is completely generated. All I have to do is, and I get a complete autofill because I'm using TypeScript. So I just have to do this .sdk. And I will get all the operations which I can do with the SDK. And this SDK is generated from the operations, or that is queries and mutations I have defined. So I use a SDL first approach. So I don't use something like type GraphQL or something which uses TypeScript. So then I define the variables which I want to pass to the respective operation. So then my job is done. So this is how we use Dgraph. So from an end-to-end flow context, as you see here, you saw me first. Okay, let me quickly take you through first defining the GraphQL schema, then connecting all the tools to the schema or dgraph using the config, then using something like GraphQL mesh as the ORM to connect to dgraph, and then finally, then defining the queries and mutations we want to do on top of dgraph, generating the SDK and types. And if you notice, all of this is done using the same schema, same dgraph schema we have so far. And then finally, generating the SDK and types. So far from this first step to this, all of these are generated except for writing the queries and mutations you want. Everything else is generated, and finally you just have to call the method. So that's how simple you make the complete stack end-to-end type. So when I'm talking about end-to-end type, it's not just the server side, right? So ultimately we are also exposing this Node.js server as a GraphQL endpoint by using schema stitching on top, and we are using code generator on the client side as well. So we get a complete client to server or client to dgraph end-to-end typed architecture. So that's what we do. So I guess that I need a bit of rest as well. So this is the wish list we have for Dgraph. In fact, I'm excited about Dgraph, to be honest, because as I told you, we have been able to make a complete end-to-end typed architecture in TypeScript and GraphQL and Dgraph with a graph database in mind. And this is the only thing which we feel would basically take it to the next level. So first one would be with the multiple unique field support. So @unique is currently supported only in one portion of the schema. It's in the, all of these are in the roadmap basically. So the Dgraph team has acknowledged it. So multiple unique field support. Next one would be cascade deletes. I don't want to have nodes which are not deleted when I do a delete on a related node, right? So I want to have cascade deletes. And then I want to have references to nodes without IDs. Sometimes IDs won't make sense. And I did, all of these have been posted in the forums. The links are available. I'll probably post these slides away, across to the community, and you can have a look at it. The next important thing would be GraphQL plus minus to spec compliant GraphQL. This would make it really exciting, especially for the ecosystem, because it would give an opportunity for all the people to use all the GraphQL tools like I just showed you. So all of these tools are not from Dgraph itself, but it's leveraging the ecosystem, right? So that's what we want to do, not build everything, but leverage the ecosystem. So that's what I had for today. And on February 3rd, I'm doing a GraphQL meetup at Prisma. So it's an online meetup. So if you want, you can join that as well, where I'll be talking about the complete GraphQL stack, not just the Dgraph stack, but the rest of the GraphQL stack as well, as I discussed today. So I'll probably drop the link. So in case you have any questions, feel free to drop it in the discuss, or you can reach me over social media in any of these places. And probably we will discuss the rest of the stuff offline. That's all I have for today. Thank you.
Thanks, Vignesh. That was a very powerful presentation. I quite enjoyed it. And guys, if you have any questions, feel free to ask on the Zoom chat.
Hello.
Or hey, can you hear me?
Yeah, Manish, we could hear you.
Okay. All right. Yeah, feel free to ask questions in the Zoom chat or on the discourse chat link that we had before. I do see one question. The question is, any plans for authentication for DQL endpoints /query and /mutate in open source Dgraph? I saw feature requests and questions in forum, and I was wondering if that's in your near future plan. So we do have ways to restrict access to those endpoints, which are all in open source, including what we call a poor man's access control, where you can set a secret in the flag when you're running Dgraph, and then any request that comes to the admin endpoint must have the same secret, otherwise it will be rejected. So there are some simple ways by which even in open source you can, for example, you can turn off mutations. That's there in open source. So there's some high level access control that you can do, but for a lot more refined access control at the predicate level, that's actually under the proprietary code base. But then again, if you do access control via GraphQL, then that's again open source. So depending upon what you're doing, because the point of the proprietary code base is target to big enterprises, and so the GraphQL, which we think is used by a lot of developers, that's all open source and that can be used. But the predicate level stuff, which which is slightly orthogonal to the GraphQL stuff, that goes to enterprises. Now, having said that, all of these functionality that we have, the enterprise functionality, it's all sort of included in the dedicated instances, the Dgraph Cloud that they just showed before in his presentation. So you can get all of that for free, and you can get a bunch of proprietary functionality for free also in Slash GraphQL, depending upon what makes sense for that audience.
Yeah, I just wanted to call out in particular, you in both Slash GraphQL and dedicated instances, you will need to issue auth tokens for both your query and your mutate endpoints. You're not allowed to call DQL endpoints without an auth token, so it's protected from the public internet.
There's another question. Is there an easier way to specify reverse edges with the add has inverse directive without having to modify schema to add reverse edge after some new type have been added? Who can talk about that?
I can take this one. So,
okay.
Yeah, so through the GraphQL schema, that's where you actually define all of the structure for how your nodes are connected. So that's the place to update it. You can't get around like not having to update your GraphQL schema, but also want to have the edge specified. So add has reverse is the way to do it. Of course, you can simply update your schema, whether that's through the web UI in Slash GraphQL or otherwise in the admin endpoints. And yeah, I think we should have examples for that in the docs already. But yeah, it's definitely updating the graphical schema is the way to go.
Yeah. And one more question by Mike. Is there a plan to keep the DB online during schema changes? Dgraph is online during schema changes, so I'm slightly confused by this question. I think what might happen is that because the queries are by default they provide the highest level of guarantees, they might be blocked on that schema change to be done before the query responds. But you can switch to a best effort query. And the best effort query would be able to respond just fine without any sort of blockage. So yeah, I don't know exactly what that means, but a lot of schema changes in Dgraph are already sort of instantaneous, which is the big benefit, right? As you are iterating over your product and you're doing your development, you can just switch from like a float to an int to a string to something else. You can just make a single item to be a list, with just like by adding brackets to it. And you can add some indices and remove some indices. All of that stuff happens completely when the database is online, and there is no quote unquote migration that needs to happen to be able to do that. And a bunch of these don't even actually migrate quote unquote the data underneath, right? So because we have distinction between the storage schema and the user specified schema, and so we can convert things. If you let's say switch from int to a float, we don't have to go back and switch everything from int to a float on storage. We can just convert them on the fly by responding back to the user. So we have a bunch of these amazing things to make schemas a lot more flexible than what you expect from a traditional relational database, which allows Dgraph to be pretty instantaneous in terms of schema changes. All right, so now we actually had on the agenda, we actually had one more talk, but we are kind of past 10 here. So what do you guys think if we postpone that to the next call, or perhaps we can have a video which comes out separately from that? Because otherwise I think we'll go over to 10:30 or something. It might be much later. Right. So Anand, I think let's do that maybe we can record it and upload it, or we can tackle it in the next community call. And I just want to see if we have more questions in the okay, looks like there's no more questions here. There was some amazing stuff that Anand was going to talk about with business rules. Sorry, we don't have time left for that. But again, to remind you guys, Dgraph Day is happening in mid-April, so please go and put your submissions through to be able to so we can hopefully select you guys to talk to speak at the Dgraph Day conference. We are really excited about it, and we are seeing some pretty amazing talks already in the list. So yeah, so please go and submit, and feel free to reach out to us if you need any help.
Manish, is Dgraph Day virtual, or are we hosting it somewhere physically?
Once everybody's vaccinated, we can do that. But yes, it would be a virtual event, just like we had the GraphQL in Space and the Go Systems conference. But hopefully we can all actually meet in person again and and actually see each other during these conferences. Next slide. All right, and next. All right, and that concludes today's community call. Again, if you have any questions, feel free to ask us. We'll be around, and Vignesh would hopefully be able to also answer the questions that you post on our forum. And the recording would be available tomorrow. And do go and check out Slash GraphQL and the Dgraph Cloud pricing. We actually want to make Dgraph Cloud completely self-service. That should hopefully happen in a month or two. But in the meantime, you do have the pricing calculator to figure out how much it would cost, and you can just reach out to us to set up those instances, which is what we are doing right now. Any parting thoughts, guys, before I conclude? Nope. All right. Well, thanks everyone for joining. Again, a belated Happy New Year, and I'll see you again next month for the February community call. Thanks, guys.
Thanks for having me.